Hello everyone, this is Cactus Rocket Team, and we are here to present our rocket, the Galileo 02. It is a rocket created to compete at the entrance category of zero point 0.5 kilometers of altitude. At this moment, the simulations have presented a average altitude of 500 meters. The rocket has a weight mass of 3 kilograms, a center of gravity located at 68 centimeters, 7 centimeters. We have the center of pressure, so that gives us a static margin of 1.6 kilograms. The engine of the rocket is composed of each motor class. It has a thrust time of 0.85 seconds and an average thrust of 362 newtons. So that gives us a total force of 310 newton seconds. The propulsion subsystem is composed of the cylinder, the engine envelope, and the nozzle. Inside the engine envelope, we have the propellant grain based on potassium nitrate and sucrose, and the islam is made out of fiberglass and epoxy resin. The motor is going to be made out of 1020 size steel. Maximum working pressure for this engine is 7.5 megapascal. But the simulating that we've done, we found that the maximum chamber pressure is 8.8 megapascal.
The ejection system consists of a cylinder piston mechanism with pyrotechnic activation, as the fireboat allocated on the bottom of the cylinder is loaded with igniters and a load of black powder. When the apogee is reached, the avionics activates the igniters, pressurizing the cylinder and applying a force on the parachute and fixation components. As the nose cone is attached to the body with shear pins, they are designed and manufactured with nylon to break under the stress applied at the piston, releasing the parachute. The Galileo's parachute system is a semi-elliptical parachute made with nylon ripstop semi-elliptical to be more efficient than a hemispherical one, producing greater drag force for a given canopy area, having an eccentricity of 0.707 and a terminal velocity of 8 meters per second. It will have 12 bores and a factor of safety of 1.5. The parachute will be connected to a U-bolt on the nose cone and the ejection piston onto the body with a linked connection using rotatory swivels, using the relation of 1.5 between the diameter of the parachute and the suspension lines. The onboard avionics system, like last year, will contain two Omega, one as the main system and two other used exclusively for the recovery system apogee detection, and common future calculations. As for the systems connected to the microcontroller, we'll utilize a storage systems to locally store data for further analysis and serves as a black box, a telemetry system with a range of 1 kilometer. One will be on ground and the other will be located on the rocket, allowing communications between those 2 points, and a recovery system to detect apogee based on high drop. This system applies a common filter to avoid erroneous readings.
The airframe has a total length of 118 centimeters and a outside diameter of 5.5 centimeters. It has a total mass of 3 kilograms and is divided into parts. One of them is the nose cone. It has a axial shape and is separated into 2 parts. The material is ABS filament. The body tubes of the rocket, they are divided into 2 different tubes. One of them is the upper body tube and the lower body tube, and both of them are made of fiberglass. Linking those 2 tubes together is the transition made of nylon and PVC. The fins are made in MDF wood and they have a proper delta shape. And fixing them is the motor spot that keeps the motor in place too. To help the stability of the rocket, the aerodynamics, there is a bolt tail at the end of it.
That's the video, and here is our contact information and social